In this talk, I will argue that the formal notions of logical validity fail to capture a unique notion of informal validity. And we try to show that by means of the squeezing arguments, okay? And after we extend such analysis to intuitionistic logic, it is possible in principle to analyze such phenomena in other non-classical logics too. But we choose intuitionistic logic because of its philosophical interest. Okay. Well, you can go to slide 3. Okay. In his famous paper, he published it in 1967, called Informal Rigor and Completeness Proofs. Kreisel proposes what he calls informal rigor, which consists, as I said here, in the precise analysis of intuitive notions present in the mathematical discourse. And one of these notions is the notion of logical validity. There, he presents 3 notions, one informal and 2 formal. The first is val phi. I call here the informal one, is the first, which means that phi is true in all structures. Why such notion is informal? Well, this is informal because the concept of structures is not specified. This definition comprises set theoretical structures, class structures. So we do not know exactly what such structures mean here. It's vague. That's why it's informal. And two following notions, the formal ones. The second is the model-theoretical. Here, which means that phi is true in all structures in the cumulative hierarchy of sets. Basically, here we specify what structures what we are talking about. This notion, the model-theoretical one, just deal with set theoretical structures. The third is the derivability in a fixed set of formal rules. Here we can use natural deduction systems, sequent calculus, tableau system, and Hilbertian system, okay? But what matters is that 2 and 3 are formal, and 1 is informal. Well, the informal notion is not reducible to the same model theoretical validity nor to the syntactical one. But here we have derivability as a sufficient condition to informal validity. We can show this first item here by an informal induction. We can take the axioms of first order logic and show that they are informally valid, and we can show that its rules preserves informal validity. And the second point, it's true because if phi is true in all structures, then phi is true in all set theoretical structures. That's why we have point 2. And then we can run the argument. We have the first 2 premises that we established before. The step 3 is the completeness theorem of first order logic. And then we can obtain that informal validity implies derivability. And then we squeeze informal validity in the formal notions, okay? Such argument can be seen as a philosophical justification of the completeness theorem, because now we can see interpretation of this theorem as bridging 2 notions of formal validity, and the informal notion is the bridge between these 2 formal notions, okay? Well, but such argument was analyzed in the literature. You can pass the slide to slide 5. Well, the first observation is that vowel is not a primitive concept. It does not capture our pre-theoretical conceptions of validity. For example, as Peter Smith points, such informal notion is a result of a refinement, a technical refinement, and without such refinement, such argument could not work. Yeah. We can see such analysis in a paper that Halbach published this year. He raises the same objection. His objection is quite the same. He points that such informal notion, it's not our pre-theoretical one. But on the other hand, we do not know what is our pre-theoretical notion of validity. Okay. The point is, a squeezing argument could not work without such a sharpening process that I wrote here in the first item. But on the other hand, it is not a problem for Kreisel because, as Juliet Kennedy and Jukka Vannanen point, such informal notion captures at least an informal notion of validity present in the mathematical practice. For example, when a mathematician is dealing with algebraic structures, and when she or he has some hypotheses, and suppose they're true, and try to reach the truth of the conclusion. In some way, the informal notion present in the mathematical practice is semantic and model theoretical in some way. The last observation is that such argument is restricted to first order logic. I am considering in the argument only first order formulas, sorry. But, and it works because first order logic is complete. Such argument would not work in second order logic, the strongest full second order logic. But it's possible to show that we can run a similar argument by in a restriction of second order logic to Henkin models. Then we can show that argument, a similar squeezing argument works, but in the case of second order logic. Okay, the essential point here is the presence of a completeness theorem. But due to the schematic form of squeezing argument, such arguments were analyzed to capture more informal notions of validity closer to the natural language. For example, we can find on Shapiro's work of 2005, defense that the model theoretical definition of logical validity captures a relevant notion of informal validity in natural language. His strategy is to consider counterparts of first order formulas in the natural language. How? Take, for example, a first order formula and read it. Then you have the correspondent in the natural language. Okay, and then, as I said, let F be a counterpart of a first order formula phi, and prem be the counterpart of a set of formulas gamma. Gamma is a set of formulas of first order logic, and prem is its counterpart in natural language. Then we can define a version of informal validity here, what I present as follows. F is a logical consequence of prem in the blended sense, if and only if it's not possible to every member of prem to be true and F false. And this impossibility holds in virtue of the meaning of the logical terms occurring in F and in the members of prem. And when I write val bf, I mean that F is valid in the blended sense. Okay. With this notion, we can run an argument similar to Kreisel's one. We can run the argument 2. We have the step 1, the faithfulness, which means that every derivable formula in first order logic, you can read, you can translate it in the natural language, and you will have a valid demonstration. Okay. Second point, we can the second premises means that the formalization of such formulas, of such natural language sentences, are valid. That's why I call here adequacy. Then, by the completeness theorem, we have that every model theoretical valid formula is derivable, and then we reach the step 4. And then we squeeze again such informal notion into the formal ones. Okay? And then we have the biconditional here, that phi f is valid in the blended sense if and only if phi is informally valid. Well, in the course of this presentation, I will present many versions of squeezing arguments to show my first point, initial point. That's why I am presenting different versions of squeezing argument. The point is to show that first order logic has many informal notions. We have another more syntactic notion of validity that we defined here. We can find such notion in Shapiro's work, which means that F is a logical consequence of prem if and only if there is a deduction of F from prem by a chain of legitimate gap-free rules of inferences. And again, val dead here, the subscript F means that F is deductively valid. Such notion, again, is informal. We can again run a similar argument to the argument 2. We have faithfulness again, adequacy we have again, because we are dealing with translations of first order logic, of first order formulas in natural language. That's why 1 and 2 hold. Okay. Again, by the completeness theorem, we have that every valid formula is derivable, and 5, we squeeze again. Okay, now we have 3 notions. The Kreisel's original one, and we have 2 other informal notions of validity. The point is, Shapiro's definitions capture of our pre-theoretical notions of logical validity? The answer is no. Why? Because the sentences themselves took into consideration are obtained by which I call here reverse translation of first order formulas. That's why we can run the argument 2 and the argument 3. Then I show here that val dead and val blended are not intuitive or pre-theoretical notion of validity, because F is obtained by the reading of first order formulas, okay? And they only work because we are considering a well-behaved fragment of natural language, okay? And then we have an objection, which was raised by Owen Griffiths. If Shapiro's argument depends on the reading of first order formulas, then there is nothing special about his informal notions. To run his objection, Griffiths presents another informal notion to show that we can run a similar argument for a similar squeezing argument, and then we have that such informal notions have nothing special about them. The only thing they have is that they consider well-defined fragments of natural language. That's why we can run squeezing argument for them. And to run his objection, he considers this notion, Valnek. It's which he calls validity in the modal sense. And he defines that F is a logical consequence of prem in the modal sense, if and only if necessarily every member of prem is true and F is true. F is true. If we can run an argument for these informal notions, then he's right. There's nothing special about the deductive notion of validity and the blended notion of validity, which we use it in the arguments 2 and 3. Okay? Those three notions only work because we are considering a well-behaved fragment of natural language. On the other hand, if the formal notions of first-order logic capture the three, which one we can say that is the informal notion of validity? If we can run an squeezing argument for each notion, we do not have an ultimate criteria to say that only one of them is our intuitive notion of validity. Then, if the formal notions of validity cannot tell what is our intuitive notion, we can say that the informal notions are, in a certain sense, underdetermined by the formal notions of validity. Okay? First order logic itself, it's mute about this answer. The axiom system of first order logic cannot tell us what is the informal notion it captures. Okay? And then this abundance of informal notions, we can say that there is an informal pluralism with respect to our informal notions of validity. Okay? That is, we have an axiomatic formal system, and we have its model theory. Both components cannot point to a single informal notion. That's why we can say that there is a form of informal pluralism with respect to our preformal notions of validity. Okay? Well, on the other hand, we have in our logical practice many different logical systems. Yeah? This is a practical confirmation of logical pluralism. And given such plurality, we can ask if such informal pluralism, which we found here in classical logic, can be extended to the other formal systems. And then we analyze the case of the intuitionistic logic. Okay. First, we present classical squeezing argument for intuitionistic logic, and then we explore alternative informal notions, and then we will argue that the multiplicity of such informal notions suggests that formal systems in general do not have a canonical interpretation. This we can find such argument, but about paraconsistent logics in Barrios' paper he published in Principia. okay? But here we are using squeezing argument to reach such conclusion. We know that the Brouwer-Haitink-Kolmogorov is taken to be the intended informal interpretation for intuitionistic logic, the probabilistic interpretation, let us say this. And we can draw from such interpretation the following informal notion. Val E, the subscript here I am using for informal intuitionistic validity. Val phi means that phi is constructively provable. Such notion is again informal because the concept construction is not specified. Many different conceptions of constructibility may lead us to different conceptions of constructivism. Okay, and intuitionistic logic itself codifies such range of constructions. Okay, here we will consider intuitionistic logic as a deductive system equipped with model theory. Okay, intuitionistic logic just has a formal system. Given such informal notion, we have that the point A, which means that every derivable formula in intuitionistic logic is valid, informally valid in the constructive sense. We can find such argument, for example, in Haitink's argument for intuitionistic logic. He takes the axioms of intuitionistic logic and show that every axiom is valid under such interpretation, and that the inference rules preserves constructive probability. Okay, and then we have again a squeezing argument for intuitionistic logic. We have the step 1 and 2, which is A and B. 3 is the completeness theorem for intuitionistic logic. And 5, we have that such informal notion is squeezed by the formal notions of validity. Okay. Okay. We can say that it happens that BHK interpretation is valid for intuitionistic logic because we can run such argument for intuitionistic logic. But intuitionistic logic as a purely formal system do not prevent us to find different interpretations for it. We can make use of Barrio's distinction about pure logic and their interpretations. In his paper, he defines pure logics are languages equipped with consequence relations, and such pure systems do not need to be interpreted. In the literature, we can find systems which have an available interpretation, and we can find systems which do not have any interpretation at all. And with respect to a particular formal system, we may have a plethora of interpretation. Modal logics are paradigmatic examples of that. The same model system can have different informal interpretations. Okay, so the fact that Brouwer-Haitink-Kolmogorov interpretation is proposed to be the intended interpretation for intuitionistic logic, nothing prevents us to propose another informal notions for which we can run a squeezing argument for it. We will explore alternative arguments for intuitionistic logic by means of the translations of intuitionistic logic in the modal logics. Okay, it's a well-known fact that we can translate intuitionistic logic within the modal logic S4. And this interpretation and such a translation we can find in this present translation I am presenting here, we can find in Tarski-McKinsey. But Gödel's translation is quite similar. The difference here is in the clause of negation. The point is, by such translation, we can prove that every intuitionistic theorem has a correspondent in S4, modulo translation T. Okay? Well, what we will do now, with this theorem in hands, we will investigate the interpretations S4 may have, and modulo this translation, we can run a squeezing argument for intuitionistic logic. Consider again this notion, this other informal notion of validity for intuitionistic logic, which is the translation, its translation in S4 is demonstrable. Okay? Such notion of demonstrability is not the same as constructive probability we presented before, because demonstrability and probability in general are not equivalent. Probability has more a local character. Probability has a local character because it's defined within the systems, and demonstrability it's not necessary is not necessarily defined in a particular system. We can understand demonstrability here as demonstrability by means of any mathematic logical correct way. Okay, we do not need to attach such notion to a particular form of system. Okay, as I said, I cited Bird's article here. Demonstrability may not consider the practical limitations of a formal system, whereas probability does so, since it's particular to the theory. And then we show that the adequacy of such informal notions for intuitionistic logic is guaranteed by the translatability of intuitionistic logic into S4. Such slide here is just to illustrate that the box operator of S4 cannot taken to be probability in arithmetical theories, for example. Gödel observes this in his article, and where he says it's to be noted that provable in a certain formal system, not all formulas of S4 holds. The formula in question is the reflexivity axiom, which says that box phi implies phi. We cannot take this axiom in axiom to interpret probability in arithmetical theories because of the incompleteness theorems. Now, to show that such we can informally prove that such notion of derivability can also be taken to be the informal notion of intuitionistic logic. We use GS4 to denote probability in S4 and VS4 to denote model-theoretical validity in S4. We said here cryptic frames, but we can use alternative model theories for S4. Okay, then if such interpretation is suitable to S4, we should expect that every theorem of S4 are theses about demonstrability, and B prime, every thesis about demonstrability is valid in S4. And then we can run a second version of squeezing argument for intuitionistic logic. Here, the structure is a little bit different because we have to use the translatability theorem. Okay, The first premise says that every provable intuitionistic formula has the translation of every intuitionistic provable formula is provable in S4. The second point, we have the assumption A, that every theorem of S4 is a thesis about demonstrability. Okay? We had two. And then by B prime, we have the step 3. Again, we use the theorem 1 to say that every S4 validity is modulo T valid in intuitionistic model, in intuitionistic interpretation, in intuitionistic formal interpretation. Okay, and then by the completeness theorem, we can squeeze certain notion into the formal ones. This is an example. The second example is an alternative interpretation, which is usually given to S4. We can find such interpretation in Stonecker, but there he considered S4.3, the system S4.3, to consider a notion of knowledge which has doxastic elements. But if we take off all of these doxastic elements, we have S4 again. Okay? And given, of course, this notion of knowledge is a very idealized notion of knowledge. Okay? And then, again, if such interpretation of knowledge is attributed to the modality of S4, we should expect that every theorem of S4 is a thesis about knowability asterisk. Yeah, because we are considering a very restricted notion of knowability. And B, every thesis about knowability is S4 valid. Given this, we can state another informal notion for intuitionistic logic, that val asterisk I means that the translation of phi is known asterisk. And then we can run again. Another squeezing argument is in the next slide. The structure is quite the same of the argument 5. You have to use again the theorem 1 of the theorem of translatability in the step 1 in the step 4, and then by the same reasoning we use it in the last argument, we can squeeze such informal notions. Sorry, in the step 6 is a asterisk instead of a prime. Okay, we can squeeze such informal notion into the formal ones. Okay, well, again, you can, thank you. By these 3 arguments, we can conclude that intuitionistic logic can equally capture, by means of squeezing argument, those 3 informal notions. And in the as it happens with classical logic, the formal system of intuitionistic logic is not able to single out an informal notion of validity. Well, none of these notions we presented for intuitionistic logic and for the first order logic can be qualified as primitive notions. And Peter Smith remarks on Kreisel's original argument also applies to all of the informal notions we presented here, included the case of intuitionistic logic. And then if we have many squeezing argument for the same formal system, what notion to choose? The informal notion we choose here is always guided by theoretical preferences, pragmatic preference, inclinations we have towards to an interpretation instead of other, okay? So such multiplicity of squeezing arguments suggests that we do not have only one informal notion of validity, okay? And we say that such underdetermination of informal notions of validity, informal validity suggests that formal systems in general have no canonical interpretation, okay? Well, thank you very much. Sorry for the connection problem, okay? And that's it.